We are going to discuss binary, decimal, and hexadecimal in these visuals. We are starting with the basic things which we have studied in our schools and colleges. I am talking about converting binary values into decimal values. To be honest, I did not know conversion of binary values into decimal values. I learned it when I studied networking and internet working. There is a difference of understanding conversion of binary value into decimal values while studying in schools and in field like CCNA. We are going to focus according to CCNA objectives. Under CCNA studies, we have to feel comfortable on converting binary values into decimal values. In other words, we have to be master in converting binary values into decimal values. It is easy because of limited binary values. Under CCNA, mostly we convert 8 binary values in most cases. And let me tell you, this is my personal observation. Why mastery is required in converting binary values into decimal values? Well, number one reason would be we are going to see some decimal and hexadecimal based addresses throughout the series, and I will show you later in the same visuals also. So we must feel comfortable with these type of addresses. If we know how binary values are converted into decimal and hexadecimal values, then definitely we will feel comfortable with these type of addresses. The other and important reason which is highly required for subnetting. We are going to discuss subnetting in later visuals where you will find the importance of it. Do keep in mind that we have to master in converting binary values into decimal values, and we have to do it without using any pen and papers. So let's start working on converting binary values into decimal and hexadecimal values. Here you can see some headings: binary values, decimal values, and hexadecimal values. We are going to discuss all of them one by one, but first let me define binary values and decimal values. Binary values consist of zeros and ones. These are binary values. Whereas decimal values are the hidden values. These are the hidden values. These values are computed from binary values, and it results something like this: 71. Now, while converting binary into decimal, we analyze the binary values. Each binary number has a base of 2. Each binary number will be multiplied by resultant value, which is obtained by multiplying the base, which is 2, with each binary number's respective power. Each binary number has a power based on its position number, seeing from right to left. The position number starts from 0. Now the very first value from the right has a power of 0, the second value from the right has a power of 1, the third value from the right has a power of 2, and so on. But we are not going to adopt this method. This type of methods are very complicated, and if we adopt this method, then definitely we have to use white papers and pen. So what we are going to do with all this now? We will calculate it in different way, the most simplest way and most suitable way for our field. There are 8 binary values, as you can see. If we write 8 values in such a way that the next value is the double of the previous value, and starting from 1, and then we apply these values on binary values, then finally each binary value showing 1 will be added and it results in decimal form. So how is that? It is most simple method to convert binary values into decimal values. What we have to do is just look at how many binary values we have. In this example we have 8 binary values. Now we have to write values in such a way that the next value shows the double of the previous value, like this, and then we are going to apply these values on these binary values. Then finally those binary values which are showing 1 will be added, and thus it results in in decimal form, like in this example 71. Now you can see here I have mentioned byte in bracket with decimal values and nibble in bracket with hexadecimal values. Now let's move towards byte. Under networking and internetworking, these binary values are not called binary values. These binary values are called bits. These ones and zeros are known as bits. Under bits, the enabled bit will be represented by 1 and disabled bit will be represented by 0. Whereas 8 bits is 8 bits called a byte. 4 bits known as nibble. So this is the reason I draw nibble here at right. While calculating bits into decimal or nibble, we are going to follow same process of writing values in such a way that the next value shows the double of the previous value, and then we are going to apply these values on binary value. Then finally those binary values which are showing 1 will be added, thus it results in decimal form. Now I am going to mention some important points. If you want to, you can note these points also. A byte consists of 8 bits. The maximum value which can be result from 8 bits is 255 and minimum is 1. Whereas nibble consists of 4 bits. The maximum value which can be result by 4 bits is 15 and minimum is 1. Now at this stage I think we are much more comfortable with conversion of binary values into decimal values. Now let's move towards hexadecimal. It is bit different than decimal values. A nibble results in hexadecimal values. As we have discussed that 4 bits give maximum result of 15 and minimum of 1. When to show values from 1 to 9, it will be shown as it is 1 to 9. But from values 10 to 15, these values are represented by alphabets. Now these are the hexadecimal values. Hexa means 6. From value 10 to 15, these are 6 values. In hexadecimal, 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 is represented by D, E is representing 14, and F is representing 15. Here you can see. Now we are almost done with conversion of binary values into decimal values and hexadecimal values. Now let's move towards the example of these concepts. Now here are some examples of these concepts. At the top of these examples, it is IP version 4 address. IP version 4 address, which consists of 4 octets. Each octet is separated by a dot. Each octet consists of 8 bits. The whole IP version 4 address is 32 bits long. We are going to discuss IP version 4 in complete detail in upcoming visuals. You can see IP version 4 address in decimal form. Right now I'm just showing you that IP version 4 addresses are represented in decimal form. Now it is IP version 6 address. IP version 6 address consists of 128 bits. IP version 6 addresses are formed in hexadecimals, which means each value of IP version 6 address consists of 4 bits. We are also going to discuss IP version 6 according to CCNA objectives, but in later visuals. For now I am just showing you some examples of decimals and hexadecimals. Now it is MAC address. MAC address consists of 48 bits. Each value you can see consists of 4 bits. There are 12 values in MAC address. Each value consists of 4 bits, and we know that 4 bits is known as a nibble. Well, what is MAC address? MAC stands for Media Access Control. When NIC network interface cards are manufactured, these network interface cards are assigned MAC addresses by their manufacturers. Now, MAC addresses are assigned to these network interface cards so that these network interface cards can be identified. MAC addresses are also known as physical addresses. Now let me share something with you. I remember that MAC addresses were very strange to me. When I learned hexadecimals, since then I am feeling very comfortable with these type of addresses. And you're going to see these type of addresses throughout the series. With this, I am concluding these visuals. Now, we have discussed binary, decimal, and hexadecimal, and we also looked some examples of these concepts. If you feel any problem, you can just replay these visuals and be prepared for the upcoming visuals. Thank you.